Hello, my name is Ariana,
I'm Maddie.
And I'm Stephanie.
and this is Calculating the Relationship of Friction Force and Kinetic Energy as an Object Goes Down an Inclined Plane. The objectives for this lab is to investigate the relationship between frictional forces and kinetic energy of an object as it slides down an inclined plane. We will determine the different frictional forces by finding the respective coefficients of friction. This will be accessed by calculating the object's final velocity as it reaches the end of the inclined plane after traveling through three different surfaces.
The forces that we used for this experiment were the force of gravity, normal force, force due to friction, and the kinetic energy was also measured. It is worth noting that since the object was dropped at an incline, the force of gravity will not equal the normal force. And since the force of gravity was the only applied force, the force of gravity was constant for all three trials.
In our system, we included the IO lab, the earth, and the ramp. There's a frictional force from the ramp that opposes the motion of the IO lab, a normal force from the ramp onto the IO lab, and a gravitational force on the IO lab from the earth. Because we made the x-axis parallel to the ramp surface and the y-axis perpendicular to the ramp surface, the force of gravity can be divided into x and y components. At the top of the ramp, before the IO lab starts moving, all of the energy is gravitational potential energy. About halfway down the ramp, there's less potential energy because the IO lab is closer to the earth. There's internal energy building up due to the friction from the ramp, and there's kinetic energy because the IO lab is in motion. At the bottom of the ramp, there's no more gravitational potential energy because the IO lab is on the ground. There's more kinetic energy because the IO lab is moving faster, and there is more internal energy because the IO lab has experienced more friction. The pie charts are all the same size because the system includes the earth, the ramp, and the IO lab, and the energy in the system is conserved.
Experimental setup. Here are the materials that we used in order to produce our data. And now I'm going to read through the procedure. The IO lab is held at the top of the incline and then is released in order for it to slide down the plane. The IO lab was released down the inclined plane on three different surfaces, which were a whiteboard, a scarf, which is safe to mention that was very thick, and a towel. The motion of the IO lab was recorded. Data was collected with tracker software and analyzed using Excel.
Hypothesize that the whiteboard will have the lowest frictional force and the highest kinetic energy, whereas the towel will be an intermediate, and the scarf will have the lowest kinetic energy and the highest frictional force acting upon the object. This is because the whiteboard is the smoothest and slickest surface, allowing for a very quick and smooth slide. The scarf is the thickest and least smooth, meaning it probably has the highest friction coefficient.
We use tracker to find the change in distance over change in time to get the velocity in the x and y direction. We then use the Pythagorean theorem to calculate the velocity at each point. We then used the velocity to calculate kinetic energy. From kinetic energy, we then found work. From work, we could find the net force because the change in position was known, and then we could calculate the overall force of gravity from the mass of the IO lab and the acceleration due to gravity, which was also equal to the y component of the gravitational force. From there, we calculated the normal force, and then we calculated the force of gravity in the x direction. And next we calculated the frictional force and used that along with the normal force to find the coefficient of friction for each different material.
These are the results obtained from our calculations. Notice that the average kinetic energy is equal to the work. This is a graph of the kinetic energy of the IO lab versus the frictional force applied to it by the various surfaces on the ramp.
Discussion points. The change in kinetic energy is equal to the force times the distance traveled by the IO lab because both are equivalent to work. We were able to observe that the force of friction exerted by the IO lab directly affects the kinetic energy of the object. To see the highest frictional force in the scarf trial and the lowest in the whiteboard trial based on the average velocities, but the final velocities were not consistent with these expectations.
Errors could have occurred from the position of the camera not being the same, which altered the displacement of the object being tracked, as well as the center of the IO lab on the tracker being clicked wasn't exactly the same due to human error. And lastly, determining when the IO lab reached the ground wasn't probably always exactly the same.
In the future, we could use the IO lab software in conjunction with the tracker software to get more accurate values for instantaneous velocity. By using the wheel on the IO lab and tracking velocity that way, we could get more accurate values in the future. And we could also use more materials or more trials to get a more comprehensive understanding of the relationship between frictional force and kinetic energy of an object in motion on an inclined plane. In conclusion, we did not get the results that we expected from our hypothesis, but we were still able to examine the relationship between frictional force and kinetic energy of an object in motion on a ramp.